and welcome you all on this educational platform. Here I am to help you with your physics course. Today also we will continue learning about motion in a plane, but this time it is relative motion. In earlier session also we had discussed about it, but let us see how the situation changes when it comes under a plane. So, शुरू करते हैं. Relative motion, but this time it is in two dimension. As we know, motion of a particle depends on the reference frame from where the particle is observed. A reference frame is a physical object to which we attach our coordinate system. It can be anything. If we are observing the motion of a kite while standing on the ground, then ground is the reference frame. And if we observe the same kite while sitting in a moving car, then that moving car is the reference frame. So velocity of kite will be different from these two different frames. Today we are going to analyze how this relative velocity can be written, how it can be measured. So as you know, relative velocity of one body with respect to another can be written as vectorially v12. This is relative velocity of 1 with respect to 2. Mathematically it is equal to v1 minus v2. So if we write this in differential form, it can be written as differentiation of r12, where r12 is position of 1 with respect to 2. With respect to time we are differentiating, that has to be equal to dr1. This is differentiation of position of 1 with respect to time and differentiation of particle 2 with respect to time. Mathematically this is how relative velocity is represented, where v1 is velocity of object and v2 is velocity of observer. So it will be velocity of 1 with respect to 2. In similar way, we can write acceleration also of particle 1 with respect to 2. That will be acceleration of 1 minus acceleration of 2. And as we know, acceleration can be written in terms of velocity. So this will be d12 upon dt, which is equal to dv1 upon dt minus dv2 upon dt. So now we have to see how equations can be solved in case of two dimension. Either it can be with the vector diagram or it can be in vector component form. So let us see how this relation can be used to solve a numerical problem or a given physical situation. So let us take one example. Here is an example in which a plane moves in windy weather due east. So direction of plane is due east, while the pilot points the plane somewhat south of east. The wind is blowing at 50 km/h directed 30 degree east of north. Okay, this is direction of wind provided, while the plane moves at 200 km/h relative to wind. What is the velocity of plane relative to ground and what is the direction in which the pilot points the plane? Let us see how this can be solved. Now if we represent velocity of plane with respect to ground by vpg, then velocity of plane with respect to wind as vpw and velocity of wind with respect to ground as vwg. So we can write vpw, velocity of plane with respect to wind, can be written as velocity of plane with respect to ground minus velocity of wind with respect to ground. As you can see, vpw can be written as vp minus vw, but since velocity of plane and velocity of wind has to be measured with respect to a common reference frame, so here I have taken that common reference as ground. From ground we are observing plane and from ground we are observing wind. So it can be written as vpg minus vwg. If we draw the vector diagram, then velocity of plane with respect to ground is given by this. Let this be velocity of plane with respect to wind, the direction of which is not known. Let it be theta. And this has to be, according to vector relation, this has to be equal to velocity of wind with respect to ground. As you can see, the relation which is written here is satisfied in the vector triangle. Let us consider the direction coordinate as it is y-axis and here it is taken x-axis. We have two unknown quantities here. One is VPG and other is theta. So if we write along y direction, then it can be written as VPG in y direction has to be equal to VPW in y direction plus VWG in y direction. As I had discussed earlier also, there should be no vector sign above the components written. So no vector sign has to be put here. Now what is the value? VPG, as you can see, is along x-axis. So its y component has to be 0. And we got 0 is equal to, this is minus 200 sine theta. You can see from here with x-axis VPW is making angle theta. So with y-axis it would be 90 minus theta, and that is with negative y-axis. So the component comes out as minus 200 sine theta plus 50 cos 30 degree. Because direction of wind with respect to ground is given, that is 30 degree east of north. It can be shown here in the diagram. This is 30 degree east of north, and on solving we will get sine theta is equal to root 3 by 8. So theta can be written as sine inverse root 3 by 8. Now if we write along x direction, again the same expression can be written. VPG in x has to be equal to VPW in x plus VWG in x. And VPG itself is along x direction, so it can be written as the whole velocity of plane with respect to ground, because the whole velocity is along x direction itself. That has to be equal to, here values are given there. This is 200 cos theta. With x it is making angle theta, so cos theta to be here. And then velocity of wind with respect to ground, which is 50 km/h sine 30 degree. And on solving, which comes out to be equal to 225 km/h. Next, I am going to analyze a very common problem that is associated with crossing of a river. So let us see if a numerical comes from this kind of condition, how it can be solved. This is crossing of a river. Let us consider a river which is of width d, and let u be the velocity of river flow. I am considering this as u, and v is velocity of boat or swimmer with respect to river. Here what I have considered is u velocity of river and v velocity of boat with respect to river, or if a swimmer is crossing the river, it has to be velocity of swimmer with respect to river. If this boat is making angle theta with the river flow, so how the situation can be solved? Because for this kind of problem, generally it is asked what time it will take to cross the river and where it will reach on the opposite shore. So let us first start with the time it takes to cross the river. As we know, time can be written as distance upon speed. The distance it has to travel to cross the river has to be d, which is along the width of river. And what is the velocity in that direction? Along d. As you can see here, u has no component in direction of d. Only v will be having a component which is equal to v sine theta in that direction. So it will be, time taken will be d upon v sine theta. From the vector relation, of course, we can write velocity of boat will be equal to velocity of boat with respect to river plus velocity of river. So whenever we have to write velocity of boat, we have to write sum of these components, velocity of boat with respect to river in that particular direction and velocity of river in that particular direction. So here I have taken these components along the direction of width of river, which is v sine theta, as u has no component along its width. It is in the direction along the length of river. So time we got is d upon v sine theta. Now if this time has to be minimum, so if t has to be minimum, then what should be the condition? This sine theta has to be maximum, and as we know, what is maximum value of sine theta? That is 1. So t minimum can be written as d upon v, where theta should be 90 degree. So if someone has to cross the river in the shortest possible time, then he has to start rowing or swimming in direction which is perpendicular to the river flow. With theta is equal to 90 degree, he will get to the opposite shore in the minimum possible time. Now, if he starts moving at direction theta with river flow, where it will reach the opposite shore. If this is the point just opposite the point it had started, and let the boat or the swimmer reaches at somewhat different point which is at a distance delta x along the river flow, that is known as drift. So drift can be written as, this is the flow in direction of river current. So drift can be written as delta x, that will be equal to, now we have to write the distance term, so it has to be speed in that particular direction multiplied with time to cross the river. Speed in that direction is c. Here u, the whole velocity is along delta x. So u has to be written as whole plus v cos theta. This is the effective velocity along river flow for a boat or a swimmer. This has to be multiplied with t. And if you substitute value of t here, it will be u plus v cos theta into d upon v sin theta. So this is the drift, which is the distance by which swimmer or the boat will be taken away in the direction of current flow. And if this has to be minimum, what is the minimum possible value of drift? We can assume a situation that this delta x can be 0. So if delta x is 0, this is the minimum possible drift. The swimmer or the boat will reach a point which is just opposite to the point it had started on next shore. So if delta x is 0, equate this equation to be 0 and we will get this to be equal to u plus v cos theta multiplied with t. As we know, t cannot be 0 because it will take some time to cross the river. So this term should be equal to 0. And what could we get? Cos theta is equal to minus u by v. It is the condition for which drift will be equal to 0. The boat or the swimmer will reach exactly the opposite point on opposite shore. For this corresponding value, time taken will be, as it has value d upon v sin theta. So it can be written as under root 1 minus u square by v square. And on solving, this will be d upon root under v square minus u square. So if distance travelled is minimum, this will be the time swimmer takes or the boat takes to reach the opposite shore. Now, is it possible that u is more than v? Of course, this is possible. When river flow velocity is more than the velocity of swimmer or the velocity of boat, then cos theta being equal to u by v is simply not possible, because in this you will get cos theta value more than 1, which is impossible. So what does this mean? It does mean that drift cannot be 0 in that case. I hope you got the concept, because river flow velocity is more than the swimmer's or the boat's velocity, then drift being 0 is not possible. But of course, in this case also, the distance travelled can be minimum. So if u is more than v, and then also we have to consider for the minimum drift. So let us write for the drift delta x, as we had written earlier also, this was u plus v cos theta multiplied with d upon v sin theta. This should be minimum, and this to be minimum, if you differentiate, it should be equal to 0. So on differentiating, with respect to which quantity it should be differentiated? It has to be with respect to theta, because theta is the only variable involved here. So if you differentiate this term with respect to theta, it will come out, this is u plus v cos theta upon v sin theta multiplied with d. Don't get confused between these two d's. One I have used for the differential and other is the width of river. If you differentiate it with respect to theta and equate it to 0, then we get cos theta is equal to minus v by u, which is now a possibility because this time u is more than v. From here, we concluded that if speed of water flow is very high, then reaching just the opposite point on opposite shore is not possible. But of course, it can be a minimum drift in that condition also, and for that minimum drift, cos theta should be having this much value. And now we can take other things also if it is needed. So this is the basic concept related to crossing of a river. Now I am going to illustrate some of the numericals based on these concepts, whether it is rain and umbrella, river and swimmers. So let us see how the problems can be solved. The first question is, a swimmer wishes to cross a 500-meter wide river flowing at 5 km per hour. Okay, so D is given here, which is 500, as all values are given in kilometer. So let us convert this also in kilometer. So that will be 0.5 km. Now what is U? This is river flow velocity. It is given 5 km per hour. Next is speed of swimmer with respect to water, that I had denoted by V. So V is given 3 km per hour. These are the values provided, and if he heads in a direction making angle theta with the flow, so the direction it is making with flow is given theta, find the time he takes to cross the river. It can be done very easily now. T can be written as D upon V sine theta. Directly I am using our result. So that would be 0.5 upon V is given 3 here, 3 sine theta. And that is 1 upon 6 sine theta. It is the time taken to cross the river if angle with river flow is theta. Next it is asking, find the shortest possible time to cross the river. If time is to be minimum, so for minimum time, theta should be 90 degree. And if it is 90 degree, time minimum would be 1 upon 6 hour. That is equal to 60 upon 6, which is 10 minutes. So this is the time taken to cross the river, and it is the minimum possible time. Do remember, when time is minimum, drift is not minimum, and vice versa. One more situation is there in which it is asking to consider all the situations of previous problem. This time man has to reach the other shore at point directly opposite to his starting point, but he is reaching at somewhat different point. Okay, so let us consider the man had started from here. He has to reach at this point, but he got to this point delta x away, which is the drift we generally denote by. We have to now find the minimum distance that he has to walk. Okay, so this delta x has to be minimum. First let us check, can this be 0? For this to be 0, u should be less than v. Is this in the previous case? So let us first check the previous case. U is given 5 and v is 3 km. So this is not possible here. U is not less than v. So of course delta x being 0 is not possible. Then what is the other case? If u is more than v and still if drift has to be minimum, then cos theta should be equal to minus v upon u. In that case it would be minus v was given 3 and u as 5. So cos theta has to be equal to minus 3 by 5. This is the value of cos theta, but it is asking for minimum distance. So let us first calculate that one. Delta x minimum. Of course we are knowing that this time it cannot be equal to 0. So let us calculate its minimum possible value. It has to be equal to u plus v cos theta multiplied with d upon v sin theta. Simply substitute all the values. U is given as 5 plus 3 cos theta I have calculated, that is minus 3 by 5. So this is minus 3 by 5 into v, which is 3 given. This to be multiplied with d upon v sin theta. Value of d, it is half kilometer, that is 0.5 upon v sin theta. V is given 3 and then sin theta. If cos theta is minus 3 by 5, sin theta has to be equal to 4 by 5. So this multiplied with 4 by 5. If you now calculate all this value, it will come out as 2 upon 3 km. So this is the minimum possible drift with the conditions that is given in the problem. One more illustration is there, and it is related to rain umbrella problem. Okay, a man running on a horizontal road at 8 km/h finds the rain falling vertically. When the man is running at 8 km/h, this is velocity of man, which is equal to 8 km/h. And at this time, the rain is falling vertically. He increases his speed to 12 km/h. Now, what is this vertical direction? This is direction of rain with respect to that running man, which is running at speed of 8 km/h. Now, he increases his speed to 12 km/h. Finds that the drops make angle 30 degree with vertical. What is this direction? This also is direction of rain with respect to the running man, but this time the man has increased his speed to 12 km/h. Find the speed and direction of rain with respect to the road. Okay, let us first start with the vector triangle. Listen very carefully. Any problem that comes from this kind of situation, which is a rain and umbrella problem, flag and wind problem, all these can be solved with the help of a vector diagram, where you have to draw a vector triangle according to the relation velocity of rain should be equal to velocity of rain with respect to man plus velocity of man. So now I am going to draw a vector triangle which should satisfy this relation. So this is velocity of man in the first case when it is equal to 8 km/h. And at this time, velocity of rain with respect to this man is vertical. So let this be the velocity of rain with respect to man. This one 8 km/h is velocity of man. If you complete this triangle, this will come out as velocity of rain because it is vector sum of VRM and VM. Now the situation has somewhat changed. The man has changed his speed, and this time direction of rain with respect to man also has changed. But this should be the same because as we know, with changing our speed, velocity of rain should not change. It will be having the same value and in the same direction. What does it mean? That in same vector diagram we can draw that other situation also. So velocity of man remains the same in direction, only change speed, that is equal to now 12 km/h. One confusion is here. I have to increase velocity of man from 8 km to 12 km. So should it be done in this direction or in this direction? If it is extended towards right, then if you see while drawing the vector triangle, this would become velocity of rain, resultant velocity of rain, which is simply not possible because velocity of rain should not change. So this must be velocity of rain that I had indicated earlier. This must be the direction of velocity of rain, whatever be the condition with man. Of course, then velocity of man, its magnitude has to be extended towards left. Now this whole is velocity of man. This time the value is 12 km/h. Now up to here it was 8 km/h. So this can be represented as 4 km/h. This time velocity of rain with respect to man is, this also is relative velocity. Let us denote this by VRM dashed, and it is making angle 30 degree with vertical. So this angle being 30 degree. Now we have to calculate speed and direction of rain with respect to the road. Okay, let us consider this as angle theta. So we have to get magnitude and direction of VR. Now in the triangle, if I denote this by A, B, C and D, in the triangle ABC, I can write tan 30 degree is equal to 4 upon AC. So from here AC can be written as 4 upon tan 30 degrees 1 by root 3. So this is 4 root 3. We got value of AC. Now consider the triangle ACD. So AC is known, CD is known. What would be value of VR? VR would be equal to square root of 8 square, that is 64, plus square of AC square, which is 16 into 3. that is equal to 64 plus 48. 112. So this is root under 112 km per hour. And what about the direction? Tan theta can be written as 8 upon value of AC is 4 root 3. So this will be 2 upon root 3. And theta is equal to tan inverse 2 upon root 3. This is the value of direction of rain and the magnitude of rain. This is equal to 4 root 7 km per hour. Finally, we got both the magnitude and direction of velocity of rain. Now, just get prepared for the next session, which is our previous year's question session. And then we can check how much we have learned till now. Till then, bye. Take care.